Hi everyone, in today's lesson we're going to talk about how to solve quadratic linear systems algebraically. But first I want to talk about what exactly they are. So a quadratic linear system is basically a system that has a quadratic in it, a y equals ax squared plus bx plus c, a quadratic, and a line, y equals mx plus b. They may not always be in y equals, but they will be in the form of an x squared as a quadratic and a singular x if it's just a line. So there are three types of scenarios that you could have. You could have the quadratic and the line intersect at two spots. So you'll have two solutions here. So you have two different sets of x, y values. You could have a situation where you have a quadratic, I just wrote it upside down, doesn't really change anything, and a line that never intersect at all. This would be something that is no solutions. And we could possibly have a situation where you have a quadratic and a line, but they intersect at just one spot right here. So this would be one solution. Our main focus for today is really going to be in this first area where there are two solutions. We may or may not touch these later on, but for now let's focus on how to solve those. So let's talk algebraically with example number 1. So example number 1, we have y equals 3x minus 6 and y equals x squared minus x minus 6. So it's clear to see that the top one is the line because it's an mx plus b form, and the second one is the quadratic because it's in ax squared plus bx plus c. Now, you may have remembered when we did the linear systems that if they are both set equal to y, then to solve, we can set them equal to each other. So step 1 is going to be to set equal to each other. So let's do that. We have 3x minus 6 equals x squared minus x minus 6. So not only do we have to set them equal to each other, but we now have to solve. So I'm going to just add that. Set them equal to each other and solve. So let's do that. I have an x squared equation. And what you should remember is that every time I have an x squared, I have to take any terms that are not x squareds and bring them to the other side so we can set it equal to 0. So we're going to minus 3x, and at the same time, we're going to add 6. Notice where I'm subtracting the 3x and where I'm adding the 6. I'm lining them up with their respective like terms. So now we have 0 equals x squared minus 4x, and then these actually cancel. So at first glance, everyone's like, ooh, I can't factor that. That's not a trinomial, but we can. Remember we discussed GCF. We could take out a greatest common factor of x, and we're left with x minus 4. And then we do a t-chart, and we get x equals 0 and x equals 4. So what you just did is that you solved for half of the problem. You found the x values of where they intersect. You need to now find the y values. So think of this picture. You have a quadratic and you have your line. So what you found was that this is 4 comma something and that this is 0 comma something. You found our x values. So the second step is actually kind of simple. All we're going to have to do is plug in to find y. Now, just like we did with linear equations, you may choose any one of the original equations. I find the line to be easier to plug into, so let's do that. So we have y equals 3x minus 6. First, I'm going to plug in 0 for x. So y equals 3 times 0 minus 6, and that gives you negative 6. So I find that it's easiest if you put it right underneath it. So I plugged in 0 for x and got out -6 for y. That's my final answer in point form. You know, this would be my y value. Now we're going to use that same line, y equals 3x minus 6, but this time we're going to plug in this x value of 4. So y equals 3, plug in 4, minus 6, and your answer there should be a positive 6. So again, finalize your answer down here. You put in 4 for x, got out 6 for y, so 6 would be the other point there. And these both are your solutions to where the line and the parabola meet. Cool. All right, I have one more example for us today. And we'll call this problem number 2. So we have 5 equals y minus x, and we have 4x squared equals -17x plus y plus 4. Now, what you should notice is that these equations are not in y equals. So it makes it a little bit challenging, but if you felt comfortable the way we solved it before in problem number 1, we can still do that. Just solve this equation for y and solve this equation for y and then set them equal to each other. So I'll do that over here. So we have 5 equals y minus x. So I'm going to add x to both sides. And I get x plus 5 is equal to y. That's the first one. And then I'll do the other one over here. We have 4x squared equals -17x plus y plus 4. So I'm going to add the 17x and subtract the 4. So you should get y equals 4x squared plus 17x minus 4. So I'm going to set this one equal to this one, now that they're both set equal to y. So I'm going to do that on the left side. So we have x plus 5 equals 4x squared plus 17x minus 4. And again, just like before, you should see that you have an x squared equation, so you need to move these two to that side. So on the same time, we're going to subtract x and subtract 5. So we get 0 equals 4x squared plus 16x minus 9. Now you should notice that you have a quadratic that we have to factor. So I have a leading coefficient. I know I can divide 16 and 4, but I can't do the same thing with 9. So unfortunately, we're either going to have to use guess and test or that AC method. So I'd like you to pause the video and figure out which method you'd like to do. Try it on your own and then hit resume for the answer. All right, I'm going to choose to do the AC method. So if you multiply the 4 and the -9, you should get -36. And the factors that I'm going to use are 18 and -2. So I'm going to bring down my 4x squared, and I'm going to replace my 16x with 18x minus 2x, and then I'm going to bring down my 9. Factor by grouping, take the first 2, second 2, and bring down the minus sign. Of the first two terms, the 4 and the 18, my GCF is actually a 2x. So I'm going to take out a 2x, and I'm left with 2x plus 9. And the only GCF between 2 and 9 is -1, really. So I take out a -1, and I divide -2 by -1, which gives me 2x. And then I'm going to do the same thing here. -9 divided by -1, that gives me a positive 9. Put what's inside the parentheses together and the outside numbers together. And then just t-chart. Set each piece equal to 0. 2x minus 9 equals 0. and 2x minus 1 equals 0. So in this problem, we're going to minus the 9 and divide the 2. That should give you negative 9/2. And in the second problem, we're going to add the 1 and divide the 2. So we should get 1/2. So since those are our x values, we need to go ahead and find our y values. So if I can label some work over here, this was step 1, get them both equal to y. This was step 2, set them equal to each other. And then step 3 is going to be to find those y values. So I'm going to choose the line. So we can use what we solved for y. So we have y equals x plus 5. I just got that from here. And I'm going to plug in what I got for x. So y equals negative 9/2 plus 5. And then I'm going to do the same thing down here. Y equals 1/2 now plus 5. We're plugging in those two respective x values. So take a minute, plug those values into your calculator, and then hit resume for the answer. All right, so the first one you should have gotten 1/2. And the second one you should have gotten 11/2. So our final answer is I put in x of 9/2 and I got out y is 1/2. I put in 1/2 as x, I got out 11/2. And those two would be your final answer. Okay, that's it for today. If you have any questions, please let us know.